Um, I think there's like 2 questions on the homework that ask you to do something such to this fashion where you have to figure out inverse sine of something. So first thing you got to realize is that this part, whatever's the inverse sine of your angle, has to be between -1, and we'll just call it my angle for right now, I guess, and 1. Does anyone understand? Anybody think of a reason why the inverse sine has to fall between -1 and 1? Any thoughts on that? Okay, what do you think, Ethan?
Because the inverse means that it's flipped, right? And
Okay.
it's like a huge number on the bottom where it'd be super small to find on the graph.
Okay, all right. That's a good thought, right? What is the range of the sine function? Whoa. What's the range of the sine function? Range. Look at the graph. What's the range of the sine function?
0 to 5.
No, between -1 and 1. So the range of the sine function becomes the domain of the inverse sine function. They switch, right? So therefore, your domain has to be between -1 and 1 for your inverse sine function. So if you ask the calculator, first thing, you have to be in radian mode to take an inverse sine. So turn to mode, make sure you're in radian, otherwise it's not going to work out. Okay, so we're going to take second inverse sine, -0.36, close parentheses, hit enter, and we get -0.37 if we round to 2 decimal places. So this is about -0.37, and we rounded to 2 decimal places. This thing must be in radians. Your calculator must be in radians. Otherwise, it's not going to work out. Okay, so we have a domain for our sine, same thing for our cosine. But for our inverse tangent, we can put anything we want in there. Okay, so there's the first idea. There's a couple problems like that, but that's pretty straightforward. Let's get into something a little bit more meaningful here. So where's my chicken scratch? Here we go. What about if we try to find the exact value for the inverse sine of the sine of 5 pi over 4? All right, so we're going to start combining these functions together, all right? So the inverse sine of the sine of 5 pi over 4. Where do you think you start? You think you start on the outside or do you think you start on the inside? If you had to take a guess. Ooh, about half and half there. What's PEMDAS? Parentheses, exponents. So what's the very first thing? Parentheses, right? Okay. So we're going to start on the inside here. So where on the bite size is the sine of 5 pi over 4? We're in the third quadrant, right? Okay. So this is somewhere here in the third quadrant, right? Here is an angle of 5 pi over 4. And on that bite size, right, that's negative rad 2 over 2, comma, negative rad 2 over 2. The first one, of course, is your cosine. The second, of course, is your sine, right? So if all of this, the sine of 5 pi over 4, right, is equal to, on the bite size, negative rad 2 over 2. So now we have this, the inverse sine of negative rad 2 over 2. So what is this asking you? Inverse sine of negative rad 2 over 2. This is asking you what angle do you have to be at in order for the sine to be negative rad 2 over 2. So remember...
Didn't you just do that?
No. Because remember, inverse sine lives either in quadrant 1 or in quadrant 4. Okay, you with me? So are we in quadrant 1 or 4 for inverse sine? We're in 4. So what we're looking for is somewhere on the bite size where the second part, the sine, is negative rad 2 over 2. And what angle do I have to be at?
45.
A 45-degree angle. But I have to put it in terms of my domain, so this has to be negative pi over 4. So, therefore, all of this stuff, the inverse sine of the sine of 5 pi over 4 is negative pi over 4. You with me on that? Okay, so how can we check that on the calculator? Here we go. Let's do this one. So here we go. We're going to turn on, hit clear. We're going to take second sine of the sine of 5 pi divided by 4. Close parentheses, close parentheses. Push enter. Notice we have a negative answer, right? Is that the same thing as negative pi over 4? It probably is, right? So let's see here. What's negative second pi divided 4? And oh my gosh, it's exactly the same thing. So we did it right. Okay? So they're like little mini puzzles. You got to work your way through them. Let's do a couple more of these. How are we doing so far? Is it making sense? All right, just take it one step at a time. Draw your pictures, draw your quadrants. Here's the third idea. What about something like this?
Is there a reason you were doing sine?
No, I'm going to do this a different one here. How about this one? How about the cosine of the inverse tangent of -1? What is the cosine of the inverse tangent of -1? Well, all right, let's think our way through this. We're going to start on the inside here. Inverse tangent, we know, lives either in quadrant 1 where it's positive or quadrant 4 where it's negative. We know that. And this is asking us for the angle whose tangent is -1. So somewhere down here in quadrant 4, I'm looking for the angle whose tangent is -1. Anybody got it?
90 degrees.
No, the tangent is -1. Okay, so remember, right? When you're down here in the third quadrant, you have a couple to choose from the bite size, right? It's either going to be rad 3 over 2, comma, -1/2, all right? Or it is negative rad 2 over 2, negative rad 2 over 2. Or it's the 1/2, comma, negative rad 3 over 2. Sorry, this one should not be negative. Okay? So which one of these produces a tangent that's -1? Yeah, not this one and not that one, right? It has to be this one because it's sine divided by cosine. So what angle is that? Negative pi over 4. So this is really asking us this, the cosine of negative pi over 4. And look, there it is right there. It's staring at you in the face on the bite size. So what would it be?
Negative rad 2 over 2.
No, it's positive rad 2 over 2 because cosines are positive in quadrant 4. So all of this stuff is a positive rad 2 over 2. You guys following? All right. So on the third box here. But what happens now? What happens if the angle you're looking for is not on the bite size? Dun, 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 dun. Yeah, you got it. What if I want, this one right here. What if I want the sine inverse, the sine of the tan inverse of 1/2? The sine of the tan inverse of 1/2. Okay, well, this is a little bit different, right? Nowhere on the bite size is the tangent equal to 1/2. That's okay. We can still draw our picture and figure out what we need to, right? It's either going to be in quadrant 1 or quadrant 4. It's a positive 1/2, so that means I'm in quadrant 1. So what I can do is now I can draw a picture in quadrant 1 of an angle theta whose tangent is 1/2. So the 1 goes there, the 2 goes there. There we go. There's the angle whose tangent is 1/2. So what does that make my hypotenuse over here? The square root of 5. Yeah, very good. Okay, we did that by Pythagorean theorem. So this is asking me for the sine of theta because I drew the angle whose tangent was 1/2. So what would the sine of theta be in this picture? Look at your picture. Yeah, it would be 1 divided by root 5, but we check that into root 5 over 5. So therefore, the sine of the inverse tangent of 1/2 is root 5 over 5. And that's the exact value. All right, let's check on the calculator real quick. So let's bring it up. And let's say the sine of the inverse tangent of 0.5. Close parentheses. And I get that. It's positive. That's good. Now I'm going to check that decimal against this decimal of square root of 5 divided by 5. And notice we do the exact same thing, so we must have got it right. You guys with me on this? Okay. Please try this one on your own, okay? Try this one on your own. See if you find, the directions are still the same. See if you can find the exact value of this gnarly thing that I'm going to give right here. How about this? How about the cosine of the inverse sine of, I can't even read my writing, is that -1/3? You guys did great. Here's what I saw a lot of people doing, okay? They started on the inside, and they drew a picture in quadrant 4, and they called that theta. And they said this has to be the -1, this has to be the 3. So that makes this side the square root of 8, which is 2 square root of 2, correct? By Pythagorean theorem. Then it's asking you for the cosine, essentially, of your angle theta, which is the adjacent, which is 2 rad 2, over the hypotenuse of 3, and you're done. And you got it right, okay? All right, here we go. 6th box. Challenging question here.
So, just
Yes.
back up. So, like,
Yes, which box?
just the last one, right?
Yeah.
So it's basically saying like the cosine of that triangle, right?
Exactly, because that triangle says the angle whose sine is -1/3. So yeah, it's all, they all fit together. Yes. Okay, here we go. A more challenging question for you. Yep, sure is. What is this? The sine of the cosine inverse of a half plus the sine inverse of 3/5. Yes, this is what we're gonna do. Okay, this is the most challenging as they get. Well, that's a lie. They get more challenging, but this is what we're doing right now. Of the 6 boxes, this is the most challenging.
Where does cosine live?
1 and 2. Yeah. Okay, so here's what we do. Take this information and draw a picture. Okay, you gotta draw a picture. So it's positive. So cosine lives in quadrants 1 and 2. So I'm going to call this angle, I'm going to just call it alpha for now. All right? And I know something about alpha. What is it that I know specifically about alpha? Yeah? The cosine is what? 1/2. So where does the 1 have to go?
On the bottom.
Adjacent. Where does the 2 have to go? Hypotenuse. Good. What does that make the third missing side? The square. No, I got something else. No. The square root of 3. Yes, this is the square root of 3. Yeah, 1 squared plus square root of 3 squared is 4, which is 2 squared. Okay? Good. So then, take a look at this piece right here. Draw your picture for the second piece. Notice I'm using a different color to emphasize. That's in quadrant 1, correct? And I'm going to call this angle beta. You got to call it something. You can call it whatever you want. I'm going to call it beta for now. What do I know about angle beta? The opposite side is 3. The hypotenuse is 5, which makes the missing side of 4. We all know and love that one. Okay? Once you've got your pictures for your individual inverse sines and cosines, here's what you do. You rewrite this as this. The sine of the angle alpha plus angle beta. Oh. And that looks familiar, doesn't it? Okay? So then, it's the sum and difference. So that's going to become sine alpha times cosine beta plus sine beta cosine alpha. That's why you've got to draw the pictures first. So, let's all look together. What's the sine of alpha? Oh, okay. All right. Yeah, if you look back at your alpha picture, which is the red one, the sine of alpha is rad 3 over 2. The cosine of beta, look at your beta picture, the blue picture. What's the cosine? There, okay, you guys are catching on now. Good. Plus, go to your, what's the sine of beta? Go to the blue picture. Yeah, 3/5. It's also given. Good. And then by the cosine of alpha. Yeah, also given, right? Okay, therefore, when we clean this up, we get 4 square root of 3 plus 3 all divided by 10, and that is our exact answer. Okay? All right. Questions, comments, concerns? How come there's a this, that? Or where did that come from? Or what's that doing there? Or how did you get this? Or anything like that? Questions going once. Questions going twice. Sold. Oh, applause, applause. Thank you.